Right. So let's see how this is practically done by the operating system, this memory management, all these tasks. Can you share your screen? So I just want to show you it in the Windows environment, and then I'll show how it is done in the other operating systems. So please share your screen. I have given the privileges. Now you can share. Now you can share, right? Okay, so let's see how this is done in the Windows environment. And now, now we have our Windows machine. So basically, I want to see how the management tasks are done. To do see that the easiest place to understand the memory management, process management, threads, and all is the task manager. To access task manager, there are few methods. So one is you can right click on the taskbar. Yeah, and go to the task manager. That is method number 1. And method number 2, also please see that method number 2, Windows and R key together, Windows and R key, Windows key and R key. Windows key, R key together, you will get the run dialog box. Windows ekai R ekai. So you'll get the run dialog box. There you can type TASKMGR. TASKMGR. And okay, then you'll get that task manager. So the same one, you get the same thing. And yes, then you can, the another method is press Alt and Control and Delete together. Alt, Control and Delete keys. Alt, Control, Delete keys together. And that is the third method of accessing the task manager. There you will get a menu. From that you can access the task manager, right? That is the method number 3. Okay, anyway, so when you get the task manager, you'll get see a window like this, and you can see the active tasks running. So these are the active processes. Some are visible processes. You can see the task manager is a visible process. Zoom is a visible process. Zoom is a visible process. And so these are background processes. You have 90 background processes, but visible processes only 3. But in the background, there are 90 supporting processes. And you can see how each process take the memory. So Zoom is taking 9 closer to 10% of your processing power. This is the total processing power, right? That total utilized processing power, and you can just click on that and then it will be sorted. You can see Zoom is taking more, and other applications consequently they also take. And memory also, you can just say 47% of the memory currently utilized. And so when you click on the memory, please click on memory and it will be sorted there. Yeah, click on memory here, this one. Right, then it will be sorted according to memory usage. And you can see again, Zoom is using more memory, right? So which proves currently running applications are in the memory. 47% is utilized now. 16% is utilized now. Currently running processors are using the processing power. Currently running applications and their data resides in the memory. So can you open another one? So let's open Opera. So what I can see here, let's open Opera, just double click there. Opera, and you can see when you open it, it will again increase the memory usage here, 48%. Now it's using 48%, and it will increase the CPU utilization also. It's closer to 40% now. Still, it's opening, I think. Right now, it's 49%. Gradually, it is loaded to the memory. Now it's 50%, and CPU went up to 80%. Right? So please go back to the task manager again. And after opening this, you can see CPU cooldown. CPU task is over now. So actually, so most of the task done by CPU is to find out the program, display it in the screen, load it into the screen with the instructions. And that task is over now, but even that task is over, you can see the memory utilization is now 52%. 52% memory utilization. Because, so it is not going to be down. It's not going, yeah, here, because, yeah, that is the issue. So you found that 172 is now for this one. Therefore, it has increased the memory. So this again proves the same theory. Currently running applications and data are there in the memory. Right. Okay, memory has a hierarchy. Memory has a hierarchy. This is our dynamic random access memory, or DRAM. This shows our DRAM. The red color circle shows our DRAM. So what is the largest memory or largest storage in your computer? What is the largest storage in your computer for the moment? Is it DRAM or something else? No, I'm asking the largest storage. Yeah, it is. You can see it's hard disk. Right? It's your hard disk. C and D together, you are having closer to 1 TB. Right? If you want to show the size of your hard disk, you can go to run again, Windows key and R. And there are a few commands to see that. Right? Then I'll show you easy method. So just close this run. No need to use run. I'll show you easy method. So can you find this PC? This PC. It's here. Yeah. Just click it. Right click it on this PC. Right click on this PC. You can right click here. This place. Right click. You can right click. Oh, open this. Open it. Open the Explorer again. Open the Explorer again. So this one. Just open it again. Open this. Whatever. Then in the Explorer view, you can see this PC here. Right click on that and select Manage. Manage. Select Manage. And there you can see the storages. And you will see, okay, here. So please go to the disk management. Disk management. Right, there in the disk management, now you can see your hard disk, basically, so what, your largest storage, that is disk 0 or your hard disk. Disk 0, here, disk 0, that is your hard disk. And disk, then again, DVD, you don't have any DVD. If you insert DVD, that will also be there. And hard disk is basically divided to small segments, which is called partitions. Simple single hard disk, you have one disk that is closer to 1 TB, but you can say 931.50 online, because why? Why don't have 1 TB?
Because the hard disk operates.
So basically in the manufacturing plant, so there are drivers. There are some software installed to any hardware drive, any hardware component has drivers.
Yeah.
Similar to that, hard disk has drivers. So the online or available amount to you is only this, because others are used by the manufacturer installed software. Also the partition table or the system file table. So then again from this also 260 is used for the boot segment. Right? And here, so this is for the recovery. 574 MB is for the recovery partition. And actually you are using this C. Actually you are using this C, the red color, and this D. The actual amount of data that you use is closer to 558 GB plus 371 GB. Together it's closer to what? Just add two numbers. 550 plus 350. It's closer to 558 plus, yeah. So closer to 900. Right? That is what it shows, right? So with this additional, it's closer to, I think, 8 plus this 20. Yeah, it's closer to, this is the online space. At the exact figure. At the exact figure. That means 558.91. No. 558.91 plus 371.77. Okay, now we can see it is similar to the online space. Can you see? Yeah, for that you can add that 2 For that, you can add 260 plus this one, and it will give you the total figure. Just add all four together.
That's in MB, no?
Sorry, 260. Yeah, that is
in
MB, but you can divide by 1024, and that is 0.8. 0.8 plus, then 37, okay, plus, right, 558.91. You can see the amount is here, similar to this one here. 39, this amount, 931.50. This is the total online amount. Total online amount. Yes, that is the total online amount. What is the offline amount? Offline amount is used for, it is not showing to you. It is for the system drivers. It is for the mechanism. It is for the recognition purpose. It is for the manufacturer, basically. It's not given to you. Right? Out of this online amount also, this is for the boot segment and this is for the recovery segment. And what is available to you is only this part and this part. And this is the largest storage in your computer. From this storage, right? From this large storage, certain amount is allocated for page file. What is that? Certain amount is allocated for page file. You can't see the page file there. Here you see, yes, you can see boot, page file, crash dump. So what is page file? Page file.
This like these things we open and stuff.
Can you see the page file? Can you show me the page file?
No.
No, not from there.
Like
you can go to the C drive. No, just go to the C drive. Just click here in the Explorer and go to the C. Right, you will not see the page file here, but you have a way to do this. So please go to the file menu here. And there you have change fold and search options. Change fold and search options. Please go there. And there you have view tab. Please go to the view tab. And there you have this untick this. Untick this. Hide protected operating system files. Just untick it. And yes, and hide. Then you have to here show hidden files. That is okay. Show hidden files. That is okay. That is done. And you can also show this hide extension for non-file types. Please untick that as well. Hide extension for non-file types. Okay, now click apply and okay. Right, now you can see here, right, now you can see the page file. So can you see the page file now? See here, this one, page file.sys, right? Page file.sys, and there's another one, struct file this.sys, and there's another one, hyperfile.sys. Don't delete these files, right? These files are very important. So, but these are as his system files. You can't see these system files in the normal occurrences. I don't open that. So you can see the properties. Yeah, it is large, but some students think if we delete this file, we can get big space. But after that, this is operating system file. Don't delete that. Right? It's very useful. The page file is very useful file because so different programs are having. So for an example, think that this is MS Word. This is Excel. Right? You have MS Word and you have Excel. You have PowerPoint. Then you have some other one. Likewise, you have few programs in your computer. So let's say this is Word, and basically you divide these words. Right, as I said, there are like various programs. Right, there are various programs in your computer. Right here. So let's say you have. So this is let's say this is MS Word, and this is Excel. This is PowerPoint, likewise. Or this is your movie. let's name this some movie, and this is Word, this is PowerPoint, and this is Excel maybe. So each of these are like having size, like movie, let's say 4 GB. Movie is 4 GB. And then Word is, let's say, 1 GB. And PowerPoint is, let's say, 1 GB. And Excel is also 1 GB. And you have random access memory. You have your random access memory also. So let's draw it here. Let's say your random access memory is only 4 GB. Then if you can't load all these things to your RAM, because this is 4 plus 1 plus 1 plus 1 is 7. You can't load 7 GB into RAM. But not that. So if you're reading a book, you are not reading all the pages at once. You read certain pages, maybe one or two. You are not using the entire program. Similar to that, you are not using the entire section, entire code, or entire data, or entire set of instructions at once. So what it does, it will divide this to a manageable chunks called pages. It will divide this to manageable chunks called pages. Pages. These are small manageable areas. Small manageable data set. This is also to pages. This is also to pages. Like, so if you have bread, you can divide it to slices or easy management or easy breakfast, something like that. And anyway, similar to that, you divide this to pages. These pages are then the frequently uses pages or required pages are then transferred to something called page file. So this page file is in your hard disk. So this is your page file. Page file. And all page files together we call. So there can be many page files. So one from your C drive, one from your D drive. Likewise, there can be many page files. Anyway, all together we call virtual memory. That is virtual memory. In this virtual memory, you have pages from different devices. Pages from Word, pages from your movie, pages from Excel. These pages are then transferred to the random access memory. This is your physical dynamic random access memory. So pages are first transferred from the hard disk storage to virtual memory. From the virtual memory, then pages are transferred to dynamic random access memory. So this is what happened inside your page file. So page file is keeping the pages related to different programs. Understood? Why you need additional storage there?
Yeah.
Right? And what is Hyperfile? Hyperfile is basically used when you hibernate your computer or when you shut down your computer without closing the programs. If you want to keep the programs as it is and shut down your computer, then Hyperfile is used. Right? Hibernate means status shutdown. Status shutdown, you are not going to load everything from the beginning. You are not going to, yes, hibernate option is there in the power option. In the power options, you have hibernate. So when you hibernate, it will save the state and shut down. So what's the difference between sleep and hibernate? Sleep and hibernate. Sleeping means, what is the difference between sleeping and hibernating? Sleeping means when you have laptop, you just close this and keep it somewhere. That is sleeping. Still your status is there, but you need battery, right? Remember that you need battery to do that. But if you hibernate, you don't need battery to keep the memory because that memory is saved to that temporary memory is saved to Hyperfile. This one. Right? When you sleep, you need battery to keep that memory. But when you hibernate, you don't need battery to keep that memory. It will save the state and shut down. Understood the difference?
Yeah.
Right? If you want to hibernate, you can go to the power options, go to the control panel, power options, just search power options. Just search power options. From the Windows menu, you can search. Right, power options. And please go there, you can see the hibernate. Or go to the control panel, there is something called power. Control panel, you have power. Power plan, change plan settings. Let's change advanced power settings. Yes, go to that. And so please drop a little. Go to sleep and see if the hibernate option is there. No. Yeah, hibernate here, sleep, hibernate after. That option is there. On battery plug, likewise, you can change the option. So into hibernate, don't change it. So then like after sleeping, it will be changed to hibernate. That means if you don't have reliable battery, you can change it to hibernate. So if you have a reliable battery, you can just keep it as it is, right? But if you don't have reliable battery, then you can hibernate your computer. Right? Oh, just search hibernate. Just search hibernate from the Windows menu. Go to Windows menu and search hibernate. Yes, power and sleep settings. Power and sleep settings. Right. Okay. Now you can see screen additional power settings maybe. Again, going to the same thing, right?
This one?
No, not the second one. Again, first one. First one. Yeah, just go to that one. So maybe change power mode. No, there's another option that's what I want to show you. Not this one. Not this one.
This one?
Yeah, power and sleep settings. It's there in the power and sleep settings. And so I think, yeah, power and sleep. Additional power settings. You went to that, no? Additional power setting, create a power plan, choose what power buttons do. Right there, you can see when I press power button, what to do. Right, hibernate here.
Yeah.
Show in power menu. You can just tick it and it will be shown. So you have to go to the change settings that are currently unavailable, and then right, okay, then save settings. Then you can see that in the power options also. When you go to the power button, you can see hibernate there, right? Okay, that's all. So try hibernate and see. Not now, later you can try hibernate and see. It's similar to sleep, but without power, you can keep the data. Okay, now you know some advanced options and you know what is the usage of, so we just wanted to learn the usage of memory and storage, virtual memory, we learned that. And then another thing, right? Then another thing. So then please go to the task manager again. Please go to the task manager again. I just want to show you the performance of your computer. Go to the second tab, performance, and there you can see the CPU. Yeah, maximize that. I'll show you one by one. The first one is CPU. It's telling you current utilization of the CPU, number of processors running, and as I said, number of threads, part of the processors, number of threads or the part of the processors are running, and the speed of the CPU. Speed of the CPU, that is also there. Right. Okay. Right, then here, it shows the basic speed of your processor, that is 2.4 gigahertz. That is the base speed of your processor, and the brand is i7. You have i7 CPU, and here they are showing some additional settings, like here see that level 1 cache, level 2 cache, and level 3 cache. So these are also belongs to the random access memory, but this is called static random access memory, SRAM. Right? This is called static random access memory, or SRAM. This is not DRAM, right? SRAM is actually these two RAMs. So I'm highlighting these two SRAMs, L1 and L2 cache, inside the processor. And L3 cache is a shared memory for all the cores. It is also attached to the processor, but not inside the processor. It's attached to the processor. So these cache memories are super fast. So these are created using, can you remember the flip-flops in the logic gate? We have not done the logic gate parts now still. Flip-flop. So the cache memories are created using flip-flops. Created using flip-flops in logic gates. So these are super fast, faster, and super faster and costly. If you want to change the cache memory, how to change that? If you want to change the cache memory,
first change the processor.
Yeah, you have to change the processor. No other mechanism, because cache memory is not detachable. Unlike the DRAM, dynamic RAM you can just remove. Dynamic RAM you can just remove and replace. But cache memory you can't replace like that. You have to remove the processor and replace the processor, right? Okay, so in the memory hierarchy, the top is registers and cache memory. The second is your dynamic random access memory. Third is your virtual memory. And fourth is your hard disk, or the secondary storage. And the fifth is network storage. Okay, if you draw a pyramid like this, in top part is registers, then this cache memories, then this DRAM, then this secondary storage, then finally the tertiary storage. And tertiary storage is large, that is network storage, very large, cheaper. Secondary storage, quite large, is also large, it is also cheaper. And then the RAM, DRAM. DRAM is not much cheaper. DRAM is not much cheaper. It's expensive and faster. Then you have these two are called SRAM. Actually, for SRAM, you have two things, that is registers and cache. Registers and cache. So caches are three types: level 1, level 2, and level 3. Right, there, here you have virtual memory. Then you have secondary storage. I think you can draw this quickly because this is not a big thing. The memory hierarchy, you should know this, right? When you know this, you can answer many questions. The last is tertiary storage. That is basically backup, network storage, and your hard disk, CD, DVD, HDD, SDD comes here. Right, the DRAM is your random access memory, SRAM is cache. And so when you go up, when you move up, it is faster. When you move up, it is costly. But when you move down, capacity is increasing. Capacity is larger when it is down. Speed and cost is high when you move up. Or you can take a screenshot either. Or you can write down this. Maybe take a screenshot, write down later. Or shall I send one? Shall I send screenshot of this?
Also, I can take.
Yeah. Okay. Right. Okay. Just save it and you can later refer this, right? Okay. So let's go back to the processor. Sorry, performance window. Let's go back to the performance window. Right. Let me erase all these things now. Now you know about this. Right. I just want to show you more about your processor. If you want to see the course here, it says logical processors 4. You have 4 logical processors, but you can't see it graphically. But if you want to see, just right click here in the, you can right click here in the empty place. Just right click here. No, here, yeah. Just change the draft to the logical process, and you can see all 4 cores in your computer. This is how the 4 independent ALUs are working.
So everything are different.
Sorry?
The graph, everything is different.
Yeah, it can be same. It can be same if it is sharing equally. But there are programs where you can unevenly share the processor. So some are created to. So most of the programs are created to evenly share this. The software engineers, most are created this to evenly share the processing power. But there are some programs which can you actually, when you are doing coding, you can unevenly share this between the process. That is also possible. Okay, then so you can see right, all these things. You can see how utilization, number of processors, threads. So threads means part of processors, right? Thread, I said this already. Thread is a part of processor. What is handler? Handlers are responsible. Sorry?
894,000.
Yeah. Yes, handlers are basically responsible. Handlers are responsible for just looking after what happened. When you move mouse, a handler will take part. When you click somewhere, handler will take part. When you right click, handler will take double click. When you press a key, when you key up, likewise, different handlers are looking at different user actions. So related to these threads, they are monitoring user actions, not just user actions, time actions, user actions, different triggers. They are looking at different triggers to pop up new processes. So you need more handlers to look at the thing, because you have this much of threads means you need more handlers. Actually, one thread. So if you divide by this 87,000 by this figure, you will get closer to 4,000. I guess, yes. 0, 0, 0 is cut down. So if you divide this by this, you will get closer to 40, right? Closer to 40, that means one thread. So roughly it has closer to 40 handlers. Not evenly, right? It's also not evenly. Each handler will not have the same amount of, each thread will not have the same amount of handlers. That is also different. Okay, now you have a big picture, and you have one socket. One socket means one physical chip, a mega chip, microprocessor actually. One physical chip. Inside that you have 2 physical kitchens. 2 physical kitchens means 2 kitchens. And logically there are 4 chefs. Right? 1 house, 2 kitchen, 4 chefs. So that is the story in short, right? 1 house, 2 kitchens, and 4 chefs. Right? If you increase the number of kitchens, number of cores, physical cores, it will increase the performance, but it will use more battery. If you increase the number of chefs, with a limitation, right? Because you can't increase this to 1,000 chefs. Then again, it will slow down because more cooks will spoil the soup, right? So if you just increase, keep increasing and increase this to more logical processes, it will slow down. But you have a limit, certain limit you can increase and speed up. But if you increase the number of physical processors for the cores, then you can speed up your processor. But again, there's a limit. Because if you again increase this unevenly, then the processor will be very large. To carry the processor, we need some big bag or big machine. Again, it will generate more heat, more power. Ultimately, it will become useless. Right? So always there's a limit. We can't increase this indefinitely. And then, okay, now you have idea about the processor management. This part is basically how. So this processor is there. This kitchen is there. You have the physical kitchen. That is this. Inside the kitchen, you have, physical house. You have kitchen. You have chefs. That is the hardware part. But who manages this? Who create processes? Who create threads? What are the handlers? The utilization, everything, utilization of cache, everything is duty of your operating system. So that is the important thing. Physical house, kitchen, chefs are there, but usage is totally up to the operating system. So OS is responsible party to handle this. Okay, let's move to the memory then. Let's move to the memory. Right, memory, here you have that page and all these stories, right? You can see 8 GB memory is now there, but you have already utilized 3.5 GB. So when you open a program, just open with Google Chrome. Just open Google Chrome and see what is happening. And you can see there's a, right. So please go to the here, you can see the change. Notice this change, yes. Notice this change. It has increased the amount of memory. And please close Google Chrome again. Yeah, it is in the figures also, it is there. Just close it and you can see it's dropping. Slower it takes in, sooner it releases, right? Okay, so this is how, and you can see page full, not full, page full. Number of pages in the page full. And none page means those are not taken from the page. This none page means those are taken from directly from the storage, not from the page, that virtual memory. These are taken from the virtual memory. This 439 is taken from the virtual memory, but this 300 is taken directly without virtual memory. That's what the story. Okay, then, so you can see there's a hardware reserved memory for their firmware, hardware reserved memory, and the speed. How fast RAM is transferring information after processing, or how fast RAM is transferring information. That is also decided. That is also a fact which decide in speed of your computer. If your RAM is faster, so even it is same 8 GB, but you have faster RAM. Let's say you have like 3200 megahertz speed RAM. So then your speed will be definitely go up.
DDR4.
Sorry?
DDR4.
Yeah, DDR4. So it has more speed, right? And then the disk means the hard disk, and Wi-Fi means that is for the Wi-Fi is for the network, and then GPU is graphical processing unit. There's a different processor for processing graphics. There's a different process for processing graphics, that is GPU. You have NVIDIA, and that you also have in a memory. So you can see more details. Go to the GPU and you can see more details of this and how video RAM is used. So it is like dedicated 2 GB RAM is there. The shared amount is from your current physical RAM. You get that from the memory. Yes, the shared amount you get from the memory. Dedicated amount, there's a separate area for that. And currently like closer to small utilization, right? But if you are using a 3D engine, or if you are using a game engine, or if you are using a 3D rendering engine, or maybe video editing tool, this will go up. So not for everything, right? If you open MS Word, this will not go up. But if you open specific graphic application, it will go up. Right? Okay, now you know full story about your computer, right? And let's move back and summarize the thing that we have learned today. Right. So we learn about these processing interfaces, providing interfaces, user management, resource management, and security and protection we didn't learn now. Actually, next day, we have to learn in the practical session, we will be learning how these files, extensions, file hierarchies, and security, especially the security, fragmentation, defragmentation, hard disk maintenance. That is also like practical part. We'll learn that in the next day. Okay, do you have any questions up to now?
No, can you show your that word T?
Sorry?
The word you used to, you wrote now and stuff, the word.
This one?
Word. I have this